welcome back to the Wolves and Moose of Isle Royale. This is our second lecture in the series of lectures that we'll have for this class. In the last class, we focused on the natural history of wolves and moose. We spent a little bit of time thinking about each of those species, and we focused on this question ultimately of, what is the life of a wolf or moose all about? What I want to do in this class period, this lecture, is to dive a little bit deeper into the natural history of wolves. And in doing so, the information this time will be a little bit more technical, a little bit more quantitative, but nevertheless, it'll enrich and deepen our understanding of wolves. And as we're going through this information, some of it will get to be a little bit more technical, a lot more graphs and this sort of thing. So just bear in mind that the web conferencing sessions that we'll have every week, that's an important opportunity for us to kind of clarify or maybe just better understand any of the material that we cover during these lecture periods. And so with that, we can start a little bit. What I want to do is go through just the different aspects of the life of a wolf, reproduction, and then the growth and development of pups, and the survival rates of wolves. And so we'll go through these various parts that describe the life of a wolf. And so first of all, reproduction. These are just basic things that just help us understand wolves a little bit better. Wolves mate once a year. They do so in the latter part of February. The females, the alpha females, are pregnant for about 2 months, 62 days on average, and this means that they would give birth in early April. Litter sizes are extremely variable from 1 pup all the way up to about 11 pups, but the most common litter sizes would be between 4 and 6 pups. Now, when biologists describe a young organism, they describe it as either being altricial or precocial. And then, of course, you could be somewhere along the middle. To be precocial means that you're born very well developed. You have a lot of abilities, right from day one. Altricial means that you're not so well developed on your first day of life. And wolves are altricial. They are born both deaf and blind. They're only about the size of a can of soda pop. Here's a picture. This is a little bit of a gruesome picture. These are all pups that are dead. They died on the day they were born. In fact, a couple of the pups had just been born, and several of the pups in here were in the womb, ready to be born within minutes or hours. The mother who gave birth to some of these pups, she died in the process of birth. It's very rare for that to happen in wolves. We don't know why it happened in this particular case, but in any event, the image just gives you a sense of what a pup is all about, what they look like anyways, on the first day that they're born. And each one of those pups, again, is just a little bit bigger than the size of your fist. The development of a pup, because they're born in this altricial state, they develop really quite rapidly. Within a few months, they're able to do a great deal more than what they could do when they were born. And so, within a month, these pups can hear and they can see. They weigh maybe about 10 pounds, and they basically spend their time kind of exploring and playing around the den site, literally within 10, 20, 30 yards or meters from the den site. During this time, the provisioning of food is primarily by the parents, and then sometimes some of the siblings of these pups, brothers and sisters that were maybe born a year or 2 previously, they will also help provision food. What happens is these older animals capture food, they bring it back to the den, and then they regurgitate some of the food that they've eaten, and it's the regurgitated food that the pups will eat. By about in age 2 months, this is going to be about late June now, the pups are fully weaned and they eat only meat. If we advance all the way up to about 3 months, now we're talking about late July, now the pups will have traveled as far as a few miles from the den site to what are referred to as rendezvous sites. Sometimes what happens is that the mother will just pick up and carry these pups to these rendezvous sites, and there they will stay. I think the thing of, sometimes when we think about dens in the context of wolves, and sometimes we can even think of like a nest for a bird, we think, oh, well, that's their home. Well, that's not such a good example. It's more like their cradle. The only purpose of a den or a nest, in the case of a bird, is just a place for the pups. It's not really where the wolves live. And so what happens is, as soon as the wolves don't need that cradle anymore, as soon as they don't need that very narrow scope of the den, what happens is they move to what's called a rendezvous site. And a rendezvous site is just some other place that's maybe closer to where the food is. Because wolves, for example, on Isle Royale, they're eating large items like moose, and wolves don't know where the next moose is going to be. It might be many miles from where the den site is. Well, when the pups are big enough, basically, rather than bring the food to the pups, just bring the pups a little bit closer to where the food is. And that's what a rendezvous site is. And basically what happens is, because this is where the pups are, this is where the alpha wolves are at, this is near where the food would be, this means that all the rest of the members of the pack will tend to come to this place, this rendezvous site, periodically, once or twice a day or something like that. These rendezvous sites will shift throughout the summer, kind of moving around. Now, some rendezvous sites are used year after year after year. They're good places to hang out if you're a wolf. Other rendezvous sites are maybe used just once and then maybe never used again. And then by September, when the pups that survive to that time frame, pups that are 6 or 7 months of age, by this time they have all of their adult teeth. They're about 80% full size. If you don't look at them very carefully, they're difficult to tell apart from an adult wolf. And now what happens is that by this time, by 6 or 7 months of age, these wolves are able to walk and keep up with the pack. And now there really is no home base, if you like, for this pack, for the wolves. They just are wandering throughout their territory. And so what happens is that pups and the growth and development of pups basically set up a seasonal pattern for what the life of a wolf is all about. In the winter time, and winter is defined pretty broadly, winter being really from about September all the way through until April, for that big chunk of year, the pack is traveling together. They are hunting and defending their territory together, spending most of their time together and not really in any one particular place, just traveling around. In the springtime, which is mostly late April, May, June, life is centered right around the den, which is where the pups are at. That's kind of the focal point. And then in the summertime, these rendezvous sites that I mentioned are kind of where life is centered out of as far as the wolves go. And now to shift topics just a little bit, I want to speak about mortality rates. And mortality rates are a concept that we'll spend quite a bit of time thinking about throughout the semester. So we'll dissect it in pretty careful manner. First of all, just a definition. A mortality rate, or an annual mortality rate, is a percent or proportion of individuals in a population that die each year. And so what we have on this graph is it shows about a 40-year time series across the bottom here, starting in the early 1970s, going to near the present day. Each bar represents a different year, and then over here is the percent mortality for each particular year. So here in 1971, there were about 40% of the wolves died. A couple of years later, 1973, only about, it looks like reading off of that graph, maybe 5% of the wolves died that particular year. There's a couple of things to glean off of this graph. The first thing is, notice how incredibly variable the mortality rate is from one year to the next. In 1 year right here, no mortality at all. A couple of other time periods, the mortality is very low, only about 5%. In other cases, the mortality rates are very high, in excess of 40%. In the big picture, in the long-term average, the mortality rate is about 25%. That's the long-term average. So even just think of the average. In an average year, 1 out of every 4 wolves die. That's a typical situation. In some extreme situations, if there's a pack of 10 wolves, maybe 4 or 5 of those wolves would die, almost half. Think a little bit about the nature of what wolves, as we'll mention, I'll talk about a little bit more carefully in some time here. Wolves are very, very much like dogs, in some important sense. They're the same thing. Domestic dogs, the animals that we keep as pets. And we know from our dogs they know, my dog knows who I am, knows who my wife is, knows who our family members are. They have a memory. They know when you come home, and they know when you're going to leave, and they know when they can even tell when you're going to go on vacation, not going to come back for a while. They know all those things, and they miss people that they're familiar with. Well, if dogs can do that with people, you can be sure that they realize, wow, my brother or my sister, they're dead, and they're not here anymore. They don't understand death in the same way that we do, for sure, but they understand, like, hey, here's this other, my brother, he was here all the time, and now he's not with us anymore. That's an important part of their lives. On average, 1 out of every 4 wolves dies every year, and that means something to them. They can comprehend that and manage to understand what that means. A couple of other things that we can glean from this graph. There's a little bit of math involved, and we don't need to understand the math behind it. But if, in a typical year, 1 out of every 4 wolves dies, that means that the life expectancy, the average duration for the life of a wolf, is about 4 years. The life expectancy is the average duration of a life. Lifespan for a species is the longest that they ever tend to live. And for wolves, that's about 12 years. These are numbers that I mentioned in the previous lecture, but just to recall them once more. Now, these mortality rates are pretty interesting things because they play such an important role for population dynamics of a wolf population. I'll explain that in the next slide, but one thing I want to remember before going on to the next slide is that for wolves across the world, one of the greatest threats that they face is high mortality rates because of people killing them. In fact, there are very few places where we can study wolves and know what their mortality rates are where humans aren't a big part of that mortality rate, either killing them by shooting them, or they suffer from high rates of roadkill, being hit by cars in many places. And anyway, so it's very rare to know what the mortality rates of a wolf population are when humans aren't involved in it. This graph that we're looking at is very, very special, has very global significance in the sense of it's pretty much the only place where we have a long-term understanding of what mortality rate looks like when humans are not involved in killing them. And one of the things we realize is, wow, even when humans are not involved with killing them, their death rates are pretty high. Okay, so now we can switch to this next idea, which is what does that have to do with the population dynamics of a wolf population? Okay, on this graph, what we have across the bottom is the annual mortality rate, and that goes from 0 all the way up to on this x-axis to 60%, and then on this axis is the population growth rate on an annual basis. We'll talk about this statistic in some more detail later, but for now, we can think of this statistic, annual population growth rate, think of it as the percent growth every year in that population. So if the percent growth rate is 40%, and if you had 100 wolves, that means that the next year you'd have 140 wolves. If you had 100 wolves one year, and then the next year you had this minus 20% growth rate, then the population would decline from 100 wolves to 80 wolves. That's how that number works. And so what happens is each one of these data points is a data point from Isle Royale for a different year. And so we can just look at any one particular one of these graphs. So in this particular case, we had a mortality rate of about 20%. 20% of the wolves died. And in that particular year, the growth rate was minus 20%. Here's another example where the mortality rate was about 30%. But in that particular case, apparently the birth rates must have been very high because that population still grew despite the mortality rate of 30%. It grew to the effect of, well, it increased by about 50%, or I'm sorry, a little bit more than 60%. So that's what the data points on that graph suggest. And if we look at what the overall trend is on this graph, it's indicated by this black line right here, what we see is kind of a not surprising pattern. When the mortality rates tend to be high, well, that corresponds to relatively low growth rates. In other words, the population shrinking. When the mortality rates tend to be low, that tends to correspond to higher growth rates where the population is growing. And we can even do a little bit more. Remember that I said on the previous graph that the long-term average growth rate is about the long-term average mortality rate is about 25%. We learned that from the previous graph. Okay, let's find that spot right here, 25%. Let's go up. and then we see, okay, where does that cross over here on the y-axis? That corresponds to about a 0 growth rate. In other words, the population is not increasing or decreasing. So, on Isle Royale at least, when the mortality rate is about 25%, then that tends to correspond to the population not growing or shrinking on average, though there's a lot of variability around that. You can see that, so just for a small range of mortality rates, in this range right here, you can be as low as, say, 20%, as high as like 30%, but you can still have quite a variation between, negative 20% and plus 10%. So even though there's this tendency in this pattern, the pattern that's indicated by this line, there's still a lot of variation. And that variation is something that we'll focus on later in the class and try to understand what it means and all that sort of thing. For now, the main point to understand, the big take-home message, is that mortality rates are a key feature of the lives of an individual wolf, and mortality rates are a key feature for the population dynamics of a wolf population. Mortality rate varies a lot from year to year, and that variability has a big impact on whether the population is going to grow or shrink. The data that I'm showing you right now focuses on Isle Royale, but it turns out the same kind of information can be gathered from populations across, in this case, the graph that I'm showing now shows across from North America. So what we have is that the x-axis is the same as in this previous graph. The y-axis is the same as in the previous graph. It's population growth rate. But now the data points are a little bit different. Here, each data point corresponds to a different population across North America. And so, for example, this population right here was maybe observed for just 1, 2, or 3 years. And in those few years that it was observed, its mortality rate was right here at about 60%, and its growth rate was right here at about minus 20%. That's how to read this graph. If you like, we can think of this graph on the left-hand side. This is taking advantage of variation that occurs over time. Every data point is a different year, but it's always the same place, Isle Royale. This graph over here on the right takes advantage of variation over space. Every data point is for just 1 or 2 years, but every data point is a different place, or in this case, across North America. Ecologists, especially population biologists, sometimes trade off. In some cases, they're looking at variation over time. In some cases, they're looking at variation over space. They're doing it for the same reason, to kind of help understand population dynamics. But it's a pretty important distinction that is made, and I just wanted to highlight it for that reason. And again, the other key take-home message from this graph is that what it is that we see on Isle Royale is very, very similar to a pattern that we see across North America. So we've got this idea, mortality rates are important. Mortality rates play a large role in population dynamics. We can go a little bit further. Mortality rate can be divided up into a bunch of different causes, and one important cause of mortality rate in many parts of the world is human-caused mortality rate, usually being trapped or hunted or poached, or, and as I mentioned, being hit by cars is a more common cause of death than is sometimes appreciated. And so this graph just highlights that not only is mortality rate in general important, but human-caused mortality rate in particular can be very important. Again, on the x-axis of this graph is the rate of human-caused mortality. On the y-axis is population growth rate. The y-axis is the same as what we saw on the previous graph. And here what we see is each data point represents a different place across North America where human-caused mortality and growth rate had been measured. And what we see here is a pretty strong relationship, suggesting that as human-caused mortality rate increases, population rate, growth rate goes down. This confirms for us this idea that one of the great threats to wolf populations in many parts of the world is the fact that humans kill them. And so it's a well-known idea. This is the kind of evidence that really drives that idea home. And I should speak a little bit about this graph. There is some controversy about this graph. Some people who are involved in managing wolves don't really appreciate this graph. They are more comfortable believing that high rates of human-caused mortality don't really matter, and their tendencies to want to believe that are probably more associated with kind of political orientations and management expediency and that sort of a thing. But this graph pretty clearly shows that's not the case. What I'm doing here in this series of graphs is, again, just kind of showing us some general things about wolves. We're kind of expanding a little bit from Isle Royale in particular, kind of thinking about wolves more generally. This graph shows different causes of death for wolves that live in the Upper Peninsula of Michigan, not on Isle Royale, but on the mainland of Michigan. It's representative of many places across the planet. And so what we find is that even though wolves are protected in Michigan, it's not legal to hunt them, we can still see that the most common cause of death is humans killing them. In fact, illegally killing them by poaching. And vehicle collisions are also an important component. Other human causes of death, in this particular case, they represent things like, in the state of Michigan, sometimes if a wolf causes trouble, like killing livestock, then the state government will go and kill that wolf. In that case, it's a legal killing, but a human cause of death nonetheless. We can see that even in a place where wolves are protected, like in Michigan, the Upper Peninsula of Michigan, the overwhelming majority of causes of death are still human-caused. Only a very small proportion of the causes of death are when wolves are killing one another. Disease is something that's a little bit more important than is sometimes appreciated. Mange is a particular kind of disease. There are other diseases that wolves suffer from. We'll talk more about that later in the class. But that's something that may be more important about wolves than we sometimes appreciate. And then there's a small collection of deaths that are difficult to categorize. So anyways, this graph just meant to illustrate what common causes of death are when humans are on the landscape. I'd mentioned in the previous lecture that on Isle Royale, by far the most common causes of death are starvation and wolves killing one another. And so that if we were to make a pie chart for Isle Royale, it would look pretty different than this graph here. So again, just kind of continuing on with different aspects of the life of a wolf and what their lives are all about. Wolves are characterized by a pretty complicated social structure. And among carnivores, this is pretty distinctive. Think of all of the carnivores that that come to mind: mountain lions, weasels, grizzly bears. These carnivores lead solitary lives. About 90% of all of the species that are carnivores lead solitary lives. The ones that live in groups are relatively rare. They're conspicuous to us. We know about them: wolves, coyotes, lions. They all live in groups. Meerkats, they're a group that we'll talk a little bit later on. They live in Africa. They live in groups. But so this is relatively rare, and so because it's rare, it captures our imagination and our attention. And so for now, just a few details about that. First of all, what is a pack? A pack is basically a family unit. It's mostly an alpha pair, a male and a female. They are the kind of quote-unquote leaders of the pack. More importantly, they're the parents of most of the other wolves that are in the pack. And so that means most of the wolves in a pack are related to one another as brother and sister. These brothers and sisters are considered subordinate wolves. Subordinate in the sense that they're not the leaders, not the alphas. And these subordinate wolves are of a variety of ages. Some of them will be pups, less than a year old. Some of them will be 1, 2, or 3 years old, even though they're different ages, have different abilities because of their different sizes and ages. They're still mostly brothers and sisters. That's the basic template. But wolf families are a lot like human families. That's just the general theme, and there's lots of variation on that theme. And wolves are a lot about, okay, here's kind of the rule, and well, okay, then we find lots of exceptions to the rules, and then we find out, well, actually wolves break the rules, so to speak, more often, or as often as they follow the rules. So it's not uncommon to have uncles or cousins as part of a pack as well. One of the things about this alpha pair is that one of the things that's definitely defining about them is that they control the breeding. It's only the alpha pair that breeds in a pack. except when that's not the case. There are some exceptions, and as we study wolves more and more, we're starting to wonder if, well, the exceptions maybe don't happen with some frequency, 10-20% of the time, perhaps. When food is really abundant, and when a pack gets very large, sometimes it seems as though a second female will reproduce. But then all kinds of things happen from there. Sometimes it's one male mating with two females. Sometimes it's two males and two females that are doing the mating. Sometimes two litters are born, but then some of the pups from the one mother, they all end up getting killed, sometimes by the other female. So a lot of complicated things occur. But anyways, as a general theme, it's the alpha pair that are controlling the breeding. They're the only ones doing the breeding. They also, again, as a general rule, they're controlling who feeds first and who feeds last. Who gets the most food and who gets the least food. Again, when wolves kill something big, like an Isle Royale, a moose, in other parts of the world, a deer or an elk, the alpha pair can deny access to food to a wolf that's maybe, we would say, misbehaving or not behaving in the way that the alpha pair would like. They also tend to control the alpha pair when they're going to hunt, when they're going to travel, when they're going to engage in some territorial defense and that sort of a thing. So with this business of pack size, we see on the slide here that the typical pack sizes are between 4 and 10 wolves. One of the things that's so important about wolves is how variable their lives are. And this slide shows that one of the key variabilities is pack size. Okay? Again, this is a big deal for wolves. Pack size is like, how big is your family? It's what a big part of their lives will be filled by, is how many other wolves are they interacting with. All of this data comes from Isle Royale. This is each dot represents a different pack in a different year. And what we see is that across the x-axis, which is pack size, the smallest pack size, if we can call it a pack, not really, is just one. And then there's a lot of instances with just a pair of wolves. This would be, if you like, an alpha pair with no pups. Maybe they've just gotten together but haven't yet bred. And then otherwise, pack sizes can go from 3 wolves, which would be the alpha pair and 1 pup, all the way up to 18 wolves, really quite a large pack. So it's really variable. This is just one place, just Isle Royale. And then the other thing that we see a little bit on this graph is that there's some relationship between pack size and the amount of food that each wolf gets. This y-axis right here is the kill rate. And in this case, the kill rate is measured as the kilograms of food that each wolf gets on average per day. This statistic of the kill rate is extremely important. We will revisit this over and over throughout the semester. And I'll just mention that it's important, point out that we're going to see it over and over again. It's how much food each wolf gets. That's the way to think of it in this graph. And what we see on this graph represents something of a mystery. And the mystery is this, is that the wolves who get the most food on a per wolf basis are the smallest packs. Okay, and the wolves that do best would be just a pair of wolves. And the bigger the pack size, the lower it tends to get, the amount of food. So this begs the question, well, if you had 9 or 10 wolves, why wouldn't those wolves just break up into 2 groups? They'd be smaller. They might be a pack of 6 and a pack of 3. And then every wolf in those 2 groups would then do better off. Why don't they do that? And it begs to this bigger question. Why are wolves living in groups at all? If it seems like the smaller the pack size, the better off they are. And so I want to just mention that as a long-standing question for why wolves live in groups. It has implications for why does any carnivore live in a group. We'll come back and answer the question in a later lecture. But for now, the main point is that pack size is really variable. Pack size not only is associated with how much food each wolf gets, but pack size is also associated with the size of the food that wolves eat. If we think about wolves throughout the world, one of the things that characterizes them is they eat lots of different kinds of stuff. In some parts of the world, one of the main sources of food would be hares, snowshoe hares, or other kinds of hares. And in other places, marmots. Marmots, this would be an example of wolves like this would be living in Central Asia. And then these prey are ranked from smallest over here to biggest over here. So this is white-tailed deer, caribou, moose, and bison getting bigger and bigger as we go to the right. And then what we see is that the typical pack size tends to increase with these different food items. What's not well known is what's the cause and what's the effect. Do they live in bigger packs because they eat bigger prey and it's the only way in order to kind of efficiently capture those prey? Or is it the other way around? Because they're eating bigger prey, they're allowed to have bigger sizes. There's just bigger pack sizes. There's just more food. We're not sure about cause and effect as far as that goes. But anyways, there's this general tendency. Moving on to different aspects of the life history of wolves, dispersal is a key part of any animal's life. When you're born in a place, you usually don't stay there. You have to usually go somewhere else to find a mate and reproduce. Wolves are no exception. It turns out that because of the social structure of wolves, the fact that they live in packs, this business about dispersal, it's kind of a complicated affair, a lot going on, some interesting things all about that process. First thing to understand, this is an obvious one, but just to point it out, when wolves are born, they're born into a pack. We'll call that their natal pack. Now, the ambition of a wolf at some point in his life is to try to reproduce. And let's think about a male wolf. But everything that I'm about to describe is just the same for females. So you're a male wolf, your ambition is to reproduce. Well, I live in a pack where my father is the alpha male. He's not going to let anyone in this pack reproduce except for him. All right, well, whatever, I'll just bide my time. Well, maybe at some point he dies. When he dies, maybe I can ascend and take over his position. Okay, well, this would be fine, except the most likely situation is then the alpha female, that's my mother. Well, mating with your mother is not such a good idea. This represents a very intense form of inbreeding. For many organisms, that's not such a good thing, including for wolves. Wolves tend to avoid close inbreeding. They tend not to mate with their parents. They tend not to mate with their brothers and sisters. It's not that they never do it. It's that they try to avoid it if they can. So that means that staying in my own pack is probably not going to be a real successful strategy if I want to reproduce sometime in my life. So I have to leave. Okay, well, I leave. Well, when I leave, I'm in someone else's territory, the territory of another pack, and I'm not going to be welcomed there. We talked a little bit about that in the last class session about territoriality, about how wolves will try to keep other wolves out. But it's the only choice for a wolf to leave their pack. Not the only choice, but one of the most promising choices is to leave the pack, but it's dangerous. It's hard to find food. It's hard to find another mate. And so what happens is that when a wolf gets to be about 2 years old, they're full size, they've got some experience, they can kind of take care of themselves, so to speak, in terms of physically speaking. And so it's at about this point that wolves start to kind of figure out, well, maybe I should try this out on my own. And they do it in a series of forays, usually. They'll leave their territory, go out on a little adventure, if you like, for maybe a few days. Wander around and get a feel for what's going on in the neighboring packs. And what they're hoping to find is, wow, maybe I found this neighboring pack and they just lost their alpha male and I can take over in that position. Or maybe I found this one little area, this one little part of the landscape where it's in between two packs. There's no wolves living here, and maybe if I go there, hang out, I can find another wolf of the opposite sex, hook up with her, and we'll start a pack here. If I do that, we have to be a pretty tough pair because we're going to have to fend off those neighboring wolves and kind of establish ourselves in an area that maybe isn't going to be so easy to do. Anyways, that's the basic idea. It's going to have to happen at a period of time when food is maybe relatively abundant. It's not going to work out so well if food is generally scarce. And so what wolves do is, if you like, they bide their time. They live in the pack, but then they kind of leave, check things out, come back to the home pack. They may realize, wow, times are tough. This entire year is just not going to be a good year. I maybe should try to, my chances of doing this aren't going to maybe improve until next year when maybe hopefully there are more prey. And so anyways, wolves from about the age of 2 are until they die or become alpha, they're trying to figure this out. Most wolves die trying to figure it out. Relatively small proportion of wolves, maybe, I can figure it out, but maybe it's something like 10 to 20% of wolves ever reproduce in their lives. Most wolves die as subordinate wolves or as dispersing wolves trying to figure it out. And, well, anyways, that's what dispersal is all about. We spoke a little bit about territoriality in the last lecture. This slide is a slide that we showed to talk about territoriality. For here, it's just meant to jog our memory that wolves are territorial. They have a piece of the land that they hang out on and then defend it from other wolves. I want to display this idea of territoriality through a series of graphs. This is a map of Isle Royale that we're looking at here. It's a map that represents what was happening not very long ago, just a few years ago, February of 2009. And this shows that at that time there were 4 packs on Isle Royale. We will, throughout the course, look at a lot of maps of Isle Royale, and so we can just begin to appreciate a few things about it. First of all, Isle Royale is a long, skinny island. Just a few basic things. At its widest point, it's about 9 miles wide from top to bottom, and it's also about 50 miles in length from one end to the other. In square miles, it's about 200 square miles. In terms of kilometers, it's about 550 square kilometers. Gives you a sense of the size anyways. This is not the proper orientation of Isle Royale. Isle Royale is kind of cockeyed so that this is basically northeast. Let me change this in a little way here. This is the northeast end of Isle Royale, and then this is the southwest end of Isle Royale. So Isle Royale is kind of on an angle. And so what this map shows is that in this particular time there were 4 packs on Isle Royale. They were kind of all lined up in a linear fashion like this. We see something that, from what I've told you so far, seems a little unexpected. We have one pack called Paducah Pack living entirely within the boundaries of another pack, Middle Pack. Well, this is one of those great examples of wolves are mostly about variation. They're mostly about here's a general tendency, and then here's all the ways in which they sometimes don't follow that tendency. The explanation in this particular case is that the alpha male and female of this pack, turns out that they are the daughter and son of the alpha pair of this pack. So there's a very close relationship between these 2 packs. In other words, Middle Pack tolerated the presence of Paducah Pack in their territory. Middle Pack didn't spend much time over here, but they spend some time over there, and so there would have been some important tension there anyways. And so this is February 2009. This is just a little while later. Eventually Paducah Pack, they don't do so well. They eventually just go extinct. They didn't produce pups that survived. One of the alpha pair, the male or the female, I can't recall which in this case, died. That left just one wolf, and they just kind of wandered around, eventually died themselves. That left just 3 packs. And then what happens in February of 2010, almost a year later, and coming closer to our current time right now, what we see is that East Pack basically just disappears. And when they disappear, Chippewa Harbor Pack takes over for that area. And then what we see, I need to just kind of make a little more space here. February 2011, 1 year later, what we see is that Middle Pack is basically just completely dissolved. Isle Royale is comprised really of just 1 pack. There are 9 wolves living in that pack at that time. There are about another 5 wolves that are running around loose at the west end of the island. They are non-territorial. There isn't an alpha male and female that are kind of operating in any organized manner. They're just basically a bunch of loose wolves that haven't got themselves organized. The reason that they're like that is because what happened is that Middle Pack, the alpha pair, died. And when they died, the remaining wolves were kind of just disorganized. This lecture is being recorded in the year 2011, and so what happens next at the west end of the island we don't know about. We're going to have to just wait and see. Do those loose wolves form a pack, or does Chippewa Harbor Pack expand and take the whole island? We don't know yet. We have to wait and see. The purpose of these graphs is to kind of show you that this territoriality is real dynamic sort of a thing, and it has implications for just the behavior of individual wolves. in all of what I was describing, the changing of those territories, the number of territories and the size of the territories, that involves and is associated with a lot of territorial behavior, a lot of fighting between wolves, a lot of wolves dying, and then along with that, a lot of population dynamics. Wolves are increasing and decreasing in abundance as all of these things are happening. So it's a pretty complicating aspect of their lives. And these graphs are very interesting, but it's kind of important. The graphs are in some important, these maps, I should say, they're a pretty sterile representation of all that's going on behind those changes. And let me just give you one story here to emphasize. The graphs that we're looking at now represent changes over a couple of year period between about 2009 and 2011. Here's a story that begins in the year 2000, and what we're looking at here is a picture of Middle Pack. Middle Pack is one of the common packs on Isle Royale, a pack that's been there for many, many years. And what we're looking at here, this is the shoreline of Isle Royale. What's up here at the top is frozen ice and snow-covered rocks. This is a liquid open water of Lake Superior. This is wintertime, so this water here is, right around freezing. It'd be about 32 or 33 degrees Fahrenheit, right around 1 degree Celsius. The wolves are standing on a shoal. They're standing in just a few inches of water, and all these wolves are bunched up. In the middle is one wolf that they're beating up on. They're trying to kill a wolf. It's a trespassing wolf, a wolf that didn't belong in Middle Pack territory. Well, what happened is, these wolves are intending to kill the wolf. After beating up on the wolf, they left. And then the wolf that remained, that was in the water, in just a few inches of water, it didn't actually die. As this picture was taken by a colleague of mine, Rolf Peterson. He's been working on the wolves for about 40 years now. I'll tell you more about Rolf Peterson in just in a later lecture. But for now, he's watching these wolves, taking this photograph. He believes the wolf that's there in the water is dead. They leave. They're flying in an airplane to see this. They fly away to go observe some other things. Well, then they come back an hour or two later. This wolf that had been in the water, they haul themselves up on shore, and they're just barely alive, bloodied and beaten up. It turns out that there's another wolf involved in all this. What we didn't know at the time, but what ends up being the case, is that there is a male wolf that belongs to Middle Pack, but he's only loosely associated with the Middle Pack at this time. He's a dispersing wolf. And he's almost certainly not in this group right here. It might be this wolf right here, might be a wolf that's not even in the picture. Anyways, when Middle Pack leaves, this dispersing male wolf that originally comes from Middle Pack, he hooks up with this female, what turns out to be female, who had dragged herself up onto the ice. From the airplane that Rolf is making these observations, literally can see the wolf, the male wolf, nursing the wounds of the female, licking the wolf and just hanging out with it. They hang out together for a couple of days. After they leave that site, Rolf and then our pilot's name is Don Glazer. I'll tell you more about Don Glazer in a little while too, and his plane. There's some interesting things there. They land the plane on the nearest place that they can, a frozen lake not very far from here. They land the plane, they go in and they collect blood that's in the ice because they want the DNA, because they want to find out who is the identity of that wolf that was so beaten up on. Okay. Well, this is in the year 2000. We weren't doing a lot of genetics at the time. We just knew that if we had that blood sample, there would be the opportunity to sometime later in the future perform those genetics, find out who the wolf is. What we eventually find is that, to make a long story short, what happens over a couple of years is that male and female wolf, the female that was wounded, the male that does the nursing of these wounds, they eventually become the alpha pair of Chippewa Harbor Pack. They don't exist in the year 2000. When they form a year or two later, they need a place to live. Well, the place they end up having to live ends up being some of the place that Middle Pack would like to live. And so Chippewa Harbor Pack ekes out a territory And who has to give up territory as a result is middle pack. And so middle pack, they sure would have wished they would have killed that wolf, because Chippewa Harbor pack becomes really quite a powerhouse for the next, well, 10 years basically. They're still present in the year 2011, doing quite well. Middle pack's no longer with us, so they kind of they suffered in some important ways. Middle pack suffered because they didn't take care of business on that one winter day in the year 2000. Okay, well, Chippewa Harbor pack, okay, that's fine. This is 6 years later. This picture of wolves, and let's just think about these wolves. It's just a photograph, right? And you look at it, oh, it's kind of interesting. There's some wolves over here on the left. They're interested in sniffing something in the snow, probably sniffing some scent marks, some urine or defecation of another wolf. There's a few wolves that are really quite alert. They're all kind of looking at different stuff, looking in different directions. You know, when you see a picture of an animal, we just look at it and we're like, oh, that's a pretty picture. It's interesting. I like wolves, and that's a nice picture to look at. But wolves, like other animals, they have a life. And their lives has something that happened to them yesterday, and something that is happening to them right now, and something that's going to happen to them tomorrow. And so there's a story associated with the lives of the animals with any picture that you can see of an animal. And here's the story that's going on behind this image right here. This picture of wolves is East Pack. And these wolves are on Chippewa Harbor Pack territory, the year's 2006. This is Middle Pack right here. This is the pack that used to live, well, they used to live right here. Well, when Chippewa Harbor Pack formed, they established a territory basically right here, and as a result, that meant that Middle Pack had to shift over to the southwest. Okay, well, that's all fine. The picture that we're looking at, these wolves, that picture is taking place right here. These are East Pack wolves deep in the territory of Chippewa Harbor Pack. Wow, how in the world and what is going on with that? That explains a little bit about, wow, they're almost certainly sniffing either the urine or defecation of wolves that belong to a different pack. That's why they're so interested. These wolves are almost certainly on the lookout, on the alert of like, oh my goodness, we're deep in someone else's pack. We better be deep in someone else's territory. We better be on guard, be paying attention. How could East Pack be so bold? Well, they could be so bold because within a few days' time of this picture being taken, East Pack killed the alpha male of Chippewa Harbor Pack. This is the carcass of the same wolf that nursed the wounds of that alpha female. And so what we see is this business of territoriality. Now we're kind of getting the whole picture. This business of territoriality, it's not just a bunch of maps. It's the lives and deaths of wolves. It occurs with great drama. You know, there isn't a soap opera that's any more complicated or dramatic in terms of social interactions between wolves. And so here's a different map. This is a map of Wisconsin for people not familiar with the Midwest. What we're talking about, of course, this on the left-hand side is a map of much of North America. Wisconsin is this area right here. That's the map that we're looking at. Wolves are beginning to recover in Wisconsin, and so each one of these polygons is a different wolf pack. And so there's quite a few. There's well over 30 or 40 wolf packs in northern Wisconsin. And so each one of these boundaries between packs, has some dramatic story associated with it, just like the one that we saw. We just don't know what those stories are. And so this is one of the ways in which the lives of wolves are really quite remarkable. To be a little bit technical about things, just to broad things off, this business of territoriality represents a special kind of competition. And so these are really general ideas in ecology. And the idea basically here is that competition comes in a lot of different kinds. And I want to just go through that taxonomy for us just to make a general point about competition. So competition can be either interspecific or intraspecific. Interspecific competition is competition between organisms belonging to different species. Maybe competition between coyotes and wolves. That would be interspecific competition. Intraspecific competition is competition between two different individuals of the same species. In this case, competition between different kinds of wolves. Territoriality is a special kind of intraspecific competition. Competition also can be described as either interference competition or exploitive competition. And so that distinction can occur at the interspecific level or at the intraspecific level. Exploitive competition is basically just this idea that you know, if you and I are competing, and the way we're competing is, hey, here's a bunch of food, and we're going to basically just see who can capture that food the best and the fastest and the most efficient, that's exploitive competition. Interference competition is where if you and I are competing, it's all about, you know, I'm just going to literally interfere with you. I'm going to physically prevent you from being in this area. I'm going to chase you. I might even try to kill you, or you might try to kill me. That's interference competition. And so territoriality is a great example of intraspecific interference competition. So anyways, just to make that general point. We talked about territories. Well, one of the key features of a territory is how big is it. One of the remarkable things about wolves is how variable they are across the world. On this graph, what we have is, we'll go through all the different parts of it. On the x-axis is an index of prey density. And so this just means over here on this side are areas where there aren't very many prey, and over here these are areas where there are lots of prey. The particular numbers, don't worry too much about them. It's just not so many prey and lots of prey are good enough for now. And then this is the mean, I'm sorry, there's a little bit of a typo. It says mean pack size. It should say mean territory size in square kilometers. And so the main thing to appreciate is look at this, the spread along this axis. This can go as small as just a couple hundred square kilometers and can be as big as 1,600 square kilometers. So, you know, this is, you know, almost a tenfold increase. Some of the biggest territory sizes that wolves have are 10 times as big as some of the smallest territory sizes that wolves hold. Each dot is for a different wolf population across North America. Isle Royale is singled out right here. Isle Royale is a place where prey density tends to be very, very high, and territory size tends to be fairly small. And so, yeah, so again, variability is the key. There's a little bit of a tendency. There's a... ecology, I would take a little bit of a tangent here before we talk about this graph. Ecology is very much this business of, is the glass half full or is it half empty in this way? When we look at a graph, what should we focus on? Should we focus on the pattern, or should we focus on the potential lack of pattern? And you could see a lot of things in the graph here. You could see in this graph, aha, it looks like there's a pattern. It looks like when there are, let me change this again here. It looks like when there are a lot of prey, let me do this right here. When there are a lot of prey, when there are not very many prey, there tends to be a big territory size. And when there are an awful lot of prey, it tends to be a small territory size. That's the pattern, okay. Well, that's, if you like, that's I'm a glasses half full kind of a person. But now remove that dot, and let's look at just this region right here, okay? And so this region right here. This is a region where, you know, basically there's not a lot of prey. That's all low prey density. But for this area where it's all low prey density, wow, there's nothing but a wide range of variation in prey size. You say you could have almost any territory size. You could have almost any territory size despite this narrow range of prey density. If you focus on that, you're maybe a little bit like, a glass half empty kind of person with respect to ecology, of like you're more compelled by the variation. You know, the best way to think of ecology is just to be teetering back and forth between, wow, there's interesting patterns there, and like, wow, there's a lot of variation there, and I wonder what explains all that variation. Okay, again, just thinking different aspects of the natural history of wolves. We are going to focus obviously a lot on the wolves of Isle Royale, but to kind of provide proper context, say some things about wolves other places. Wolves eat a lot of different things as you go across North America or across the planet. We showed one graph already that gave some indication of that. This is a map of North America showing a few things. If we look at this place right in here, these are populations of wolves that are studied, indicated by all these green dots. In these places, the most common prey item are white-tailed deer. If we look at some other places where wolves have been studied, these are areas here. Each dot is the location of a different study site. In those particular places, wolves are eating mostly moose. Here's one study site where wolves are eating mostly bison. Up here it's caribou. There will be a region in here where it's a mixture of caribou and moose. And then there are places around here in the Rocky Mountains, kind of central and southern Rocky Mountains, where the primary prey are elk. The main point is the primary prey for wolves are almost always large ungulates. But the nature of that large ungulate varies. And the lives of wolves can really change a great deal, because on the one hand, you have elk that are living in groups, large groups. They're social animals. They live in large herds. But then you have moose and deer that are largely solitary. You have these animals here, like white-tailed deer. The white-tailed deer are relatively small, very, very fast. You have moose and bison that are not so fast, but extremely large. And so the life of wolf is pretty different depending on the kind of prey that it's eating. A lot could be said just about that, but I think we'll leave it at just that for now anyways. Other interesting relationships between wolves, their prey, and snow. And I want to illustrate that through a series of maps. And this is a map of the Upper Peninsula of Michigan. For people not so familiar, again, this is on the right-hand side, this is a map of North America. And the Upper Peninsula of Michigan is right here. It's that little area highlighted in red. So that's the map that we're looking at here. On this map, if you don't mind, I took this graph from another document. Pay no attention to the black line. It doesn't mean anything for us. But these different circles, they show the different locations of packs. Just basically approximately their location. And then the different sizes just show the different pack sizes. What I want you to see is just this general tendency. Hey, there's a lot of wolves here. Not quite as many wolves here. And then no wolves right here at all. Just pay attention to just that basic pattern. And one of the things that we see is, oh my goodness, maybe not surprisingly, but interesting nonetheless, this corresponds to where deer densities are greatest in the Upper Peninsula of Michigan. The deer densities are greatest right here in these dark colors, and then there are really relatively few deer right here in this northern area of the Upper Peninsula, and also similarly this region right here. Not so many deer. Let me just ask a question. Okay, well that's just fine. Okay, there's not many prey, and that's fine. That's not why there's so many wolves there. But what is the explanation between, why not so many deer here? What's going on there? Here's what's happening here. It's got to do with snow depth. This is, again, another map of the Upper Peninsula of Michigan. These dark areas show places where snow depth is the greatest. Here's what's happening. This right here is a shoreline. This is the southern shoreline of Lake Superior. For context, in relationship to this map, Isle Royale would be about right here. Okay? So anyways, this is the southern shoreline of Lake Superior. What happens is that when there's a north wind blowing in the wintertime, that creates what's called lake effect snow, and the snow is very deep along these areas because of that, what we call lake effect snow. So what's happening is that climate is driving where the prey are, and where the prey are is driving where the predators are. And this ends up being it's a pretty important relationship, and aspects of this relationship can be found really throughout the world. Wolves are affected by their prey, and prey are pretty importantly affected by the climate. Climate that may vary over space, like what we're showing here, and climate that may vary over time from one year to the next. Kill rates. I spoke a little bit about kill rates already. We saw that once. We're going to see it again right now, and it's going to be something we revisit over and over again. A kill rate is an important part of the life of a wolf. It's also a statistic. It's a number. And that number, or statistic, it represents something real specifically, either the number of kills per wolf per day. Sometimes it's calculated as the kilograms of food that are captured per wolf per day. So it's a number. It's a statistic. It's an important statistic because it represents two things. It represents, as I already mentioned, it represents food for the wolves. It also represents an important cause of death for the prey on Isle Royale, that's moose. And so what happens is that the kill rate is this really fundamental connecting feature between predator and prey. It's important for understanding any predator-prey relationship. And it's calculated in a variety of different ways depending on the species that you're looking at. But for wolves, the way that it is calculated is through this kind of simple bit of arithmetic right here. It's the number of kills that are observed throughout a period of time divided by the pack size of the wolves that were making those kills, and divide that by how long it was that you were watching. You know, maybe you watched for a month or for 6 weeks or something like that. To kind of make this a little bit more concrete, here's a map of Isle Royale. It depicts some findings from a little while ago from the year 2001. Each dot represents the location of a different wolf pack. I'm sorry, each dot represents the location of a different place where wolves killed a moose, and then the colors represent the different packs. So this is middle pack over here. There were 6 wolves that year, and then these are all the kills that they made. This is Chippewa Harbor pack. In that particular year, there were just 3 wolves, and these are all the kills that they made. During this particular year, we made these observations by watching wolves for about 40 days. And so to estimate kill rate, what you would do is you would just say, okay, well, for this group right here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm sorry, 1, 2, 3, 4, 5, 6, 7. That was 7 kills. That's right here. Divide that by 3 wolves that made up that pack. Divide it by the 40 days that we watched wolves that year. And that's, oops, we went ahead here. I didn't want to do that. That's the way in which you estimate the kill rate, okay? So it takes a lot of work to get just one number. And if you only had that number, the one number of kill rate, you'd be, oh, what are you going to do with that? It's just one number. When you do all that arithmetic, 7 divided by 3 divided by 40, it's just whatever. I don't know the number off the top of my head. 0.04. Well, what are you going to do with that? Well, with just one number, not much. But if you do it a lot, year after year, for as many packs as you can, then you learn some things. On Isle Royale, we've calculated that one number 3 times a year. Once for each of the packs that tends to live on Isle Royale. 1, 2, 3. It's been done now every year for 40 years. 40 years times 3 packs, that's 120 times. We now have 120 estimates of kill rate. If you do something once, well, like what are you going to do with that? If you do it 100 times or more, then you can learn some things. I have a little trouble with, hold on one second with my slideshow here. Let me just do one thing. Little transition problem here, but here we're back on track here. What this graph represents is if we take all of those kill rates and we just ask, what's the typical space between kills? Is it a few days or a lot of days or whatever? And so this is the number of days between kills. This is of all those more than 120 or more than 100 observations of kills. Well, what we can see is that very typically there's about 5 to 8 days between kills. And that, if we look at this a little bit more carefully, that happens about 15% of the time. But there are several instances or occasional instances where it may be as much as 16, 18, 22 days between kills. And then there's quite a few times when they're making kills maybe every 2 or 3 or 4 days. So one of the things that we can see is, we get a little bit of a hint of it, is the kill rate is pretty variable. But even though it's variable, there is a tendency, and the tendency is that a pack of wolves will kill moose about once every 5 or 6 days on average. I want to present this data to you in kind of a different sort of a way now. I'd mentioned that the kill rate has been estimated for many, many years. And so this graph depicts that idea. So in the first year that kill rate was estimated, it was the year 1971. And when it was estimated, it was once for each pack. And so these X's represent those different kill rates. And then this is the value of the kill rate, the kills per wolf. In this case, it's measured per month. We don't have a lot of context yet. This is about 0.7 or 0.8 or something like that. All we need to know for the moment is that, well, this one was a little bit lower than these other two. And if that's all you knew, you're just like, oh, well, okay, that's fine. That's what the kill rate is. That's 1 year's worth of effort. The next year, 1972, there's 3 more estimates of kill rate, and so now altogether we got 6 estimates of kill rate. The next year, 1973, it's filling out a little bit. We get more of a sense of where these kill rates tend to be. 1974, 1975, jumping all the way to 1980, jumping all the way to 1991, and jumping all the way to the year 2000. We've estimated kill rates all the way up to the present day, the year 2011. I stopped the graph here just because this is enough to make the point, is that the impression you have at the beginning is like, well, whatever, there's some kill rates are high, some kill rates are low. What we see now is a real sense of, again, this variability of like, oh my goodness. Well, let's look at this. If this is the average kill rate, okay, something, or we should say typical kill rate, something a little less than 1, one of the things that we can see is that, well, when times are good, we'll say, so to speak, times up here, these wolves are getting, this is maybe only about 0.7 or something. This is 2 to 4 times as much food as when times are bad down in here. And again, each one of these X's represents data collected for a pack for an entire winter. Imagine what life is like when in some winters you get 2 to 4 times as much food as in other winters. And let's just suppose that what wolves typically get is what they need. And so that means in some years they're getting, quite a bit more than they need. And in other years they're getting a fraction of what it is that they need. And of course you can better believe that in these years, these are the years when wolves are dying. And sometimes in very large numbers. Remember, we said mortality rates can sometimes be as high as 40% of the wolves dying in a particular year. Moving on to other parts of the life history of a wolf. We talked a little bit in the previous lecture about wolves being gluttonous, that sometimes we portray them as such, as being wasteful with their food, as killing more than they need. And the graph that we saw before suggests that this is a possibility sometimes as well, that they kill more than they need. And then they kill something and don't eat most of it. And so I've been involved in performing necropsies on, oh boy, well over 500 moose in the 20 years that I've been working on wolves. And what I'd like to do is just kind of show you what's typical. What's typical is indicated by this picture here. This is a carcass of a moose, and all that remains is the skull, which is what we see in the foreground here. This is the vertebral column. These are some ribs. Most of the ribs are chewed off, at least partially, and this is the pelvis back here. The leg bones, some of the heavier leg bones, femurs and humerus and stuff like that, they're scattered about the scene here. There's no meat left. There's no meat left here except for, little shreds, literally little shreds, individual muscle fibers attached to the vertebrae. The hide has been eaten entirely. Most of the hair is gone. The rumen, this big digestive sac that the moose has, a rumen on a moose is about this big. The rumen on a moose has a thin layer of skin around it that's muscle. It wouldn't be so different from the muscle lining that makes up our stomach. Wolves have even eaten that muscle lining on the rumen in a case like this. Some of the smaller bones have been broken and the marrow inside has been eaten. This is what's typical. Very, very little left. If we want to make comparisons, there are precious few human hunters, people who hunt moose or white-tailed deer or elk, that would utilize their hunted prey to this degree. And this is the typical situation. What happens sometimes is something like this, where they don't eat as much. Here there's a lot more tissue left, a lot more muscle is left on the side here. Most of the hide is still there. Okay? Well, what's happening here? Well, let's just leave it at that. What happens sometimes, it looks more like this occasionally. Here, pretty little has been eaten. The wolves have chewed a little bit off the nose. They've chewed a little bit of the hind quarter. Ravens have poked the eyes out. Some creatures, this would be a little bit of foxes, a little bit of wolves chewing on the ears. That's about it. Well, this doesn't look like very much utilization. If you're inclined to think that there's something wasteful going on, this would be a candidate for that. Well, there's a couple of things going on here. The first thing that's happening is that the wolves that made this kill were only two wolves. It takes 2 wolves a long time to eat a carcass. And the other thing that's important about this is that this kill was made deep within the territory of this particular pack. It might take them 7 or 8 days to eat this wolf. In that time, wolves have other things they have to do too. They have to protect their territory, and so wolves may have to leave this carcass to go and do some territorial defense, and then they will come back. The other thing is it's not what happened in this case. We were able to know what the wolves were doing, and we visited this carcass after they had left to do some of that territorial defense. We made some investigations, then we left ourselves, and the wolves later came back. But what happens sometimes is that when people stumble upon a carcass of a wolf-killed prey, whether it's deer or elk or moose, they find it like this, and they think, well, how wasteful. Well, you know what? You may have just chased the wolves away and they're not done feeding on it. This is not the normal situation. And even if there are instances where wolves don't eat everything, other scavengers do end up eating stuff. And we know from studies other places that those scavengers, their livelihoods actually depend on some of these opportunities to scavenge. Anyways, here's a graph with some kind of hard numbers and data attached to it. This data is from Isle Royale. Each data point here represents a different year in Isle Royale. This is what the kill rate is for that particular year. So the numbers, no need to pay close attention to them except for to just understand that's a low kill rate. This is a high kill rate. This is the proportion, estimated proportion of the carcass that was utilized. These are one of the things that we estimate when we do a necropsy on moose that wolves have killed. And so this is, again, estimate of what's going on. One of the things we can see, again, we can look at patterns, we can look at variation, we can look at this general pattern of when they kill more, they tend to consume a smaller portion of the carcass. When they tend to kill less often, they tend to utilize the carcass more thoroughly. We'll talk about that pattern in great detail in a later lecture, but what I want to focus on is just what these numbers are. In the very lowest case, they were still using about 80% of the carcass, and in one case, they're using about 99% of what is edible on the carcass. Overall, this represents a very high level of utilization. Wolves are not gluttonous, they're not wasteful, they're eating a great deal of what's going on. And so now what I want to do is I want to wrap up with just a couple of moments here of reflection and thought, looking back and thinking forward a little bit. We've talked about wolves and moose. We've asked ourselves, why would we be interested in wolves and moose? And we considered a couple of different answers. And what I want to do is just remind ourselves of that question. So we thought a little bit about why wolves are so interesting to humans. Well, one reason that they're of interest to us is that they are sometimes, as indicated by this picture on the left, they are important symbols of things that are good about humans and for humans. This is a statue depiction of Romulus and Remus, the founders of Rome, being suckled by a wolf. Here we honor the wolf. Over here on the right-hand side is a depiction of Little Red Riding Hood. Here wolves are symbolized of something evil and dangerous and bad for humans. So wolves, they capture our imagination because they're these important symbols. And one of the things that I've tried to do is to explain to you and share with you that wolves are interesting for their own sake, as just fellow denizens of the planet that we live on. But there's something more about wolves. Wolves are also interesting, not only for their own sake, but because there's something about us in wolves. And when we look at wolves, there's a reflection about us. and it's a reflection about our overall relationship with nature. And so what happens is that wolves indeed, whether it be for good or for bad, they in some important ways represent how we get along with nature and the terms upon which we will get along with nature in general. And what I want to do in the next lecture is talk just a little bit about that idea. And then just so you can see a little bit moving ahead forward, after we talk about that general idea, in the following lecture, we're going to start to focus and zoom right in on Isle Royale and talk about some of the methods that we use to study the wolves and moose on Isle Royale. We're going to focus on the island itself to kind of understand its biogeography, because that plays an important role in understanding the wolf and moose population dynamics there. So that's where we're going to be headed in the next few lectures. And that concludes the information that I want to share with you today. And we'll talk to you again soon. Thanks so much. Bye now.